Before we start talking about factor by grouping, let's review basic factoring real quick. For example, 15x cubed minus 21x y. Let's look at the common factors between the two terms. First, let's factor the numbers separately. So 15 and 21. Now you can look at my previous video on how to do the greatest common factor tree, the prime factorization. But for now, I'll assume that everybody has good knowledge of it. So 15 can be 5 times 3. Now, 5 is a prime number, 3 is a prime number, so we can't move forward. That's it. 21, 7 times 3. Again, they're both prime, so we stop. Now, let's look at the common factors between the two trees. Let's see what's common between them. 3. 3 is a common factor. So 3 is common between the two numbers. So that means I will pull the 3 out as a common factor, and the 5 minus the 7 will be inside the parentheses because that's what's left in the tree. So I pulled what's common outside, pull the common number outside the parentheses, and whatever is left over stays in the parentheses. So let's go back to the original problem. We pulled the 3 out, and 5 is still in the parentheses minus the 7. Okay, it's minus because the original problem had a minus. Now let's factor with the variables. The first term has x cubed. The second term has xy. What is the common factor between the two? Well, the common factor when it comes to variables means the variable with the least power. The common variable with the least power. So this is x cubed and this is x. So the variable with the least power is x. Now, there's no more letters or variables in the first term. We have a y here, but I cannot factor the y because it's not common. So y belongs only to the second term. Now, I will factor the x out. Who will remain if I take x out of the x cubed? How many x's do we have? We have x squared because I took one of the x's out, 2 are remaining. I took one of the x's out, but this term only has one x. So nothing is left, no more x's left, but I still have my y that I haven't factored. So looking at the numbers, looking at the letters, this is the final factoring. Ready? The numbers, we have 3 as a common factor. The variables, we have x as a common variable. Okay, factor. Parentheses, 5 x squared, so that's for the first term, minus 7y. And this should be your final answer. Let's look at one more example and then we'll start talking about factoring by grouping. Let's factor the following polynomials. 12 x to the 4 y squared z plus 16 x squared y cubed. Okay, first let's factor the numbers as always. So 12 would be 4 times 3. 3 is a prime number, so yummy 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 goes in the tummy. 4 is a composite, so the frog will jump again. You get 2 times 2, prime number, they go straight to the tummy. Now let's look at the 16. Again, 16 can jump into 4 times 4. Then each 4 can jump into 2 times 2. Prime, yummy, same here. Prime, yummy, awesome. We have 4 prime bugs settle in the tummy. Now, let's look at who's common. Let's see what the two frogs have in common. Well, in my tree here, I have a 2 and a 2. Cool. So one of the 2's goes into the heart. They have 2 in common. Any more commons? Okay, I can get another 2 common. Is anything else common? Well, no. So 2 times 2 is a 4. So my GCF is 4. The product of the two common factors. Okay, so I'm going to pull the 4 out. This is my GCF. Then, who's left after the common factors were taken out? From the first term, the 3 was left. She's so lonely by herself. Okay, now look at the next term. When I took the common factors out, who were left alone? Oh, 2 of them. They're not that lonely, but they're still alone, right? So 2 and 2. 2 times 2 is 4. So the plus sign stays the same, and you have 4. So these are the lonely guys after the common factor left them and went out. This is the lonely guy after the common factors left out. Now let's look at the variables. You have x to the 4th and x squared. Who has the smallest power? X squared wins, so x squared leaves out. Now, when x squared left, how many x's remained here? Oh, that's easy. 2, because 4 minus 2 is 2. Now, let's look at the second term. X squared left. So is anyone left here? No, it left. No one is left over. So nothing goes here. Nothing goes here. Now, z is only here. So what else can be a common variable? Y. Awesome. So y squared and y cubed. Who has the least power? Y squared wins. So y squared will leave as the greatest common factor. Since y squared left, no y's are left here. Okay, y squared left. Oh, so there's one y left here, which is awesome. Now, z, we only have z in here. There's no z's here. So z cannot be common, so it just stays where it is. And that should be how you factor this expression. Okay, Now it's time for factor by grouping. There is about 5 to 7 steps on how to factor by grouping. So take notes. I'll give you a few minutes to take notes. Please pause the video. Take good notes of the 5 main steps. Read them carefully, then resume your video. Okay, now let's apply the 5 steps to the following example. Basically, this is a little bit more complicated than the simple factoring that we used to do. We have 4 terms, and we're going to factor them by grouping. That means we're going to divide them into 2 groups. So first, look at the problem and decide, does any of my 4 terms have anything in common? Do they have greatest common factor? Okay, so x cubed and x squared and 3x, they do have x in common, but the 15 does not have. So usually we like to arrange terms from the greatest power to the least power. That will help us group them easier. Okay. Now, combining the first 2 terms and the last 2 terms. Okay. So my first group is x cubed minus the 5x squared. My second group is the 3x minus 15. Now, let's find the greatest common factor of each group separately. So, I'm going to take my first group, which is x cubed minus 5x squared. Oh, that looks familiar. That's the simple factoring that we just did. Now, we don't have a number for x cubed, no coefficient, no number here. So we don't need to worry about factoring the number. Now, x cubed and x squared, who has the least power? X squared. So that's your greatest common factor. Now, I took the x squared out. So who's left here? Just a simple x. The sign stays the same. And then here, I took the x squared out, so 5 is left by itself. That's easy. Okay. So I wrote it down, x squared times x minus 5 in the parentheses. Now, let's look at this second group. It is 3x minus 15. Now, that's an easy one. We have numbers, but 3 is a prime, baby. It's a prime bug. No factoring is needed. 15 is 3 times 5. So, we can simply say, okay, that's clear. The common factor has to be the 3. So I'm pulling the 3 out. X will be left. The negative sign stays the same. Now, if I pull the 3 out of the 15, I'm left with 5 inside the parenthesis. So this is the second group. Now, look carefully to the following expression that we just wrote down, right in that red box. Do you see anything in common? Whoa, that is so clear. That is so clear. Happy, happy, smiley face. Ooh, the x minus 5 is so clear to be common in the two. So, in that case, We say, okay, we're going to put the x minus 5 as the common factor, and we're going to take these two babies and put them in parentheses. So x squared plus 3. Again, order doesn't matter, so you can put the x squared plus 3 first, then the x minus 5. And that should be your answer. Okay, let's look at one more example. Factor 4x squared plus 20x minus 3xy minus 15y. Again, we're looking at factor by grouping, so we're going to group each two terms together. So I'm going to group the 4x squared plus 20x. Then we're going to group the minus 3xy minus 15y. So let's do the 4x squared plus 20x. So we have 4x squared plus 20x. Now for this example, the coefficients are so easy, so I'm going to skip prime factorization. If you still feel like you need more help on prime factorization, you can rewind that video in the beginning, look at the example one more time. But if you look here, you can see that 4 can go into 20 because 4 times 5 is a 20. So just by looking at the 4 and the 20, I can tell it's the greatest common factor. Again, if you need more help on that, look to the other videos or the beginning of that video and you will see how I factor them out. So 4 is my greatest common factor. Again, I have the parentheses. We factored the 4 out, so nothing is left here. We took the 4 out of the 20, so what's 20 divided by 4? 20 divided by 4 is 5, and the plus sign stays the same. Now, look at the variables, the x's. You have x squared and you have x. Who has the least power? X. So that becomes your greatest common factor. Now, let's divide x squared divided by x. Just one x is left. Again, we had 2. 1 is out, so 1 is left. Here, we have no x's left because we already factored this one out. So, you will get the 4x times the x plus 5 inside the parenthesis. Now let's factor the second group. Negative 3xy minus 15y. Oh, that's a good one too. Again, I do not need to sit here and prime factor 3 because 3 is a prime number. So basically, you can't do any more factoring for 3. 15 can be factored into 5 times 3. Well, now you see there's common. The 3 is common. Okay? Now, you see how this term is negative? And this term is also negative? And we don't like negative numbers that much, don't we? So we can factor the negative out as well. So we can say, okay, my greatest common factor is negative. Then the 3. Now let's look at the letters. We have x. No x is here, so we can't factor it out. We have y and y. Oh, we can factor the y out. Now, let's have your parentheses. I took the negative 3 out and I took the y out, right? Negative 3y, because they're common factors. So who's left? X. I took the negative out, so there's no more negative. It becomes a plus. I took it out, so it becomes a plus. Now, I took the 3 out of the 15, so who's left? Again, 15 divided by the 3, which is your 5. And that's it, because the y was already taken out. So, we're going to get negative 3y as a common factor times the x plus 5. Do we see the common, guys, between the two now? Absolutely. Look in that square. Who's common? Smiley face. Smiley face. Yay, x plus 5 is common. So we can write the x plus 5. That's the common. Then you take the first two guys and the second two and put them in their own parentheses. So the 4x minus the 3y, they make the second parenthesis. Again, order does not matter, so you can flip-flop. And that should be your answer. You should always check to see if there are any more factoring to do, but in this case, there's none. So you're good to go. Now it's your turn to have fun with factors. Try these 6 problems and let me know how it goes.